So we've got all this melting ice. Well, that ice has got to go somewhere. And it does. It goes in the ocean, right? And then the ocean rises. So you've probably heard of sea level rise. And sea level rise has already been happening. In the past 100 years, so do keep in mind this is over a long period of time, the ocean has already risen about 6.5 inches. Depending on where you are in the world, it's actually been higher for some places, it's been lower for other places. Really depends on where you are in the world, but the average sea level rise is 6.5 inches. The reason this matters is because nearly 5 million people in the United States, so this isn't talking worldwide, 5 million people in the United States live less than 4 feet above high tide, which means they ain't that far from the water. And this has happened all over. So here's a dilapidated house. I mean, it looks like it could use some TLC, but it has been abandoned. It's probably been abandoned for decades. But sea level rise has already caught up to it. It's already picked it up by the base. So we've already seen sea level rise affect communities. In the Outer Banks, we actually see this quite a bit. You'll see lots of houses that are kind of in the water, and again, because of sea level rise. The other issue with sea level rise isn't just like, oh, the water's increasing a little bit every year. It's that when you think of storms, those storm surges are going to be higher because the water is higher. High tide is going to be higher because the water is higher. So even if it's not higher all the time, there's different natural phenomena that are going to make that water level higher. And so it's really important, especially for people in coastal towns, is really thinking about, okay, how am I going to be affected? My parents' house is only about a foot above sea level. And so we're talking, I mean, if it floods, like we're the first to go. So really, really big issue. And the reason for this is, one, when those glaciers melt, that was ice sitting on top of land. Well, that water's got to go somewhere. Antarctica, if you're not really familiar, Antarctica is a big continent. There is land underneath all that ice. So when Antarctica melts, that ice goes into the water, which then increases sea level rise. Fortunately, though, Antarctica is growing, but it's not a lot. So Antarctica might not be contributing too much, but those glaciers typically are. Now the Arctic, I will say, the Arctic is not contributing really anything to sea level rise. And the reason is I want you to think about a cup. So let's say you get a cup of water, and you put, so I don't know about you guys, but I put my ice cubes in it first, and then I pour the liquid on top of it. The Arctic is like these ice cubes. So the Arctic is essentially, as I said before, Arctic, is like a big iceberg. It is ice floating in water. Well, when your ice cubes melt, your water level doesn't rise. It stays the same, right? Because you've already put those ice cubes in. It's already accounted for that difference. So as the Arctic melts, it's actually not affecting sea level rise. Like that water was already displaced because the Arctic is an ice cube. Now that doesn't mean it's not a big deal. There's a whole bunch of organisms that rely on the Arctic and really rely on the Arctic so that solar radiation gets bounced back. But just know that it's not at least contributing to sea level rise. So I guess that's good. So it's all about our sea level rise. Now let's take a look at one last thing. It's kind of taking a look at organisms, which humans are organisms as well. We're kind of being affected economically by all these changes that climate change has thrown at us, but nature is being affected as well. Some organisms are winning and some of them are losing. So for example, insects. Insects are enjoying this climate change. It's getting warmer earlier, it's staying warmer longer. Insects rely on warm weather. So insects emerge more. Now, this could be really beautiful insects like monarch butterflies, or it can be things like mosquitoes and ticks, things that spread disease. This is not only spreading things like malaria and typhoid fever and all sorts of diseases, but also think about our agricultural pests. We have more of them now because they can live longer. They have more chances to breed and more chances to multiply. So this is directly affecting humans. This is also affecting other organisms. So here we have a moose. In Canada, the moose population is being decimated by ticks. So the amount of ticks has been increasing because, again, their breeding season's a lot longer now. Ticks breed really quickly, and so they've been attaching themselves to moose and literally killing the moose through this parasitism. So it's incredibly sad, right? Like, they've been finding moose carcasses that had thousands of ticks on it. And there's not much the moose can do. A moose is trying to move to colder regions, but they're running out of those colder regions. Another thing that's happening, so you think about insects can affect a lot of different things, but also habitats are changing. Some organisms, they're fine with it. Maybe that organism lived in cool habitats and warm habitats, and it's really not that big of a deal. Some organisms aren't as lucky. So this is a picture. This guy is a little rodent. This is called the American Pika. This is actually where the name Pikachu comes from, for those of you who are interested in Pokemon. So this is a Pika. And this little rodent is actually only found on certain mountains because it actually tolerates a very narrow range of temperatures and needs a certain amount of snow for the time of the year for it to complete its life cycle and for it to be successful. But the thing is, because of climate change and because of the warming they're already seeing, what's happening is that, so if we have this mountain, let's say the Pika is found in this band. Well, because it's getting warmer, they actually need to move up. They need to move up here now. And the thing is they're running out of literally running out of habitat. There's going to come a point where they can only be at the mountaintop, and there's going to come a point where it gets too warm at that mountaintop, and they're not going to be able to survive. So the American Pika is one example, but there's actually a lot of species that are having this issue. Other species are lucking out. Other species love warm weather, so they're enjoying it. Now the thing is, you're like, well, that's cool. I don't really care about the American Pika. I don't eat it. One, is telling us things are changing. But two, maybe something we do care about eats that. Maybe bald eagles eat them. I don't know. But thinking about back to our first unit, we talked about the interconnectedness of organisms. And even if one organism we don't really care about, it may have unintended consequences to humans because maybe it affects something that we do care about. Also, climate change is happening a lot faster than evolution is. A lot of people will say, like, oh, well, organisms can just evolve. Organisms that have slow reproductive cycles, for example, humans have slow reproductive cycles, it takes us a lot longer to evolve versus insects, which have very, very short reproductive cycles. So it's not a question of, oh, well, the moose will evolve and it'll be fine. Like, no. The insects will evolve and they'll probably be just fine. Maybe some bird species might evolve and they'll be fine, but no. Most organisms that you know about, most organisms we rely on, don't have enough time to evolve. So this all sounds like doom and gloom, and well, it kind of is, because this is what we're living with now. But there is an organization out there that is trying to stop this, or at least is trying to become more organized and more educated on the issues. So this organization is called the IPCC. This is the Intergovernmental Panel on Climate Change. And what these guys are, or what this panel is, it's a panel of over 2,000 scientists representing most of the countries around the world. And what they do is every 6 years they get together and they review every single piece of literature about climate change that's been published in the past 6 years. Essentially what they're trying to do is they're trying to compile all of this research and all of this data into one document. And so they're getting John's research and Kate's research, and they're getting all of this research that come from all different sides of the spectrum. People looking at sea level rise, people looking at the American Pika, people looking at insects, people looking at hurricanes, people looking at everything. And they get all that together to come up with one report. Now from that report, they also make predictions. And that's pretty much what the IPCC is really known for. So although they make this huge report, they're really known for their predictions. So they create these different climate models. So on this graph, the climate models are being shown here. And what these climate models are doing is they're predicting, okay, here's what our future climate will look like based on our different scenarios. And by scenarios, this best one, this RCP 2.6, this is essentially best case scenario, that we enact really strict policies that limit the amount of fossil fuels we're burning, that limit the amount of wood we're burning, that gets a hold on our methane, and we start turning our life around. And if we do that, we can expect that the change in the amount of this centigrade of the Earth will actually be about 1 or so. So 1 degree increase, which is what we're currently at. So this is saying, okay, you know what? Here is where present day is. If we start changing now, we can keep it at where it is. And then hopefully after some time it'll go down. Then you've got these intermediate scenarios. This is, you know, we do a little bit, we do a little bit more. And this worst case scenario is we don't do anything. We're just like, that's cool. We'll just do whatever. We're not going to have any laws. We're just going to do whatever we want. And if that happens, the IPCC, based on all of this research that's reviewed, they say, okay, it's going to be about 4 degrees if that's the route we take. Hopefully, neither one of the, or hopefully that won't happen. Likely, this really nice one, probably not going to happen. What's likely going to happen is something in between. And whether this gets a little higher or a little lower is really going to depend on what the world does. How seriously are we going to take it? How quickly are we going to act? So just know the IPCC is making these models, but these models aren't just, oh, let's just take a guess. They are basing it on the research of thousands of other people. And this is a huge collaborative effort. So I'd like you to do, this video that's popping up is based on the IPCC models. It is a picture of the Earth's globe and their predictions for temperature changes over the next 100 years. Now remember, these temperature changes aren't same around the world. It's different. Some areas are getting warmer, some places are getting colder. This video shows 2 scenarios. It shows a best case scenario and it shows a worst case scenario. And really compare them, especially stop at 2080, I think is the highest year it goes to. Stop there and kind of compare between the 2 scenarios. And look at Maryland. Look at the difference in Maryland. 2080 is our lifetime. 2080 is your kids' lifetimes and your grandkids' lifetimes. We will see that. So the question is which scenario do we see? Do we see best case scenario? Or do we see worst case? Or do we see something in between? So go ahead, pause here, take a click on this link that's popping up, and then come on back. So climate change is already here, and it's going to be here to stay for at least a little while. How long it stays is really going to be dependent on us, and that's what we're going to explore in our next topic, looking at kind of ways that we can address this. But the biggest thing is just knowing that we're already seeing it. Temperatures have been increasing for the past 2 decades. Storms are already getting worse. We're already having more severe droughts. We're already having more severe flooding. Insects are already emerging earlier. Species are already going extinct. Like, these are things already happening. And I don't think people realize the severity of that. This isn't something that we can say, oh, it'll be bad in 10 years. I don't need to worry about it now. We needed to worry about it 20 years ago. So we can make changes. And that's what we're going to explore next.